Hello, hello, good morning all. Welcome to Civil Engineering ETAB channel. I hope you are enjoying the sessions on this channel. Today I have shared one of the video how to qualify for GATE for civil engineering. You can watch that video also. And one more thing, what I can tell you here is, please like, share, and subscribe my channel. Okay. Good evening all. Today I am going to start the properties of soil topic. Today I am going to start about the properties of soil topic. See students, in the properties of soil, in the previous session we have discussed what is void ratio, porosity, air content and all. The today's session we are going to discuss about specific gravity. Today's session I am going to discuss about specific gravity. First I will start with specific gravity. Now you can ask me, what exactly do you mean by specific gravity? You will ask me, what exactly do you mean by specific gravity? First of all, what do you mean by specific gravity means? It is the ratio of unit weight of solids is the ratio of unit weight of solids to the unit weight of water. What do you mean by specific gravity? It is the ratio of unit weight of solids to the unit weight of water. It is the ratio of unit weight of solids to the unit weight of here. See here students, G is represented as formula G is equal to gamma S upon gamma W. Here G is written as G is equal to gamma S upon gamma W. Now you can ask me, whenever I told you G is equal to gamma S by gamma W, sir, exactly what is the practical application to study about specific gravity? Whenever you are studying about specific gravity, if you take a material, some material X or a soil, that material, how much it is heavier than water, can be known using this concept. Using specific gravity, you can know a material how much it is heavier than water. That you can be knowing. And to convert weight to volume, if you want to convert weight conversion into volume conversion, you will learn about specific gravity. And a material is floating or sinking. A material will float or sink also depends upon specific gravity. A material, whether a material means a body is floating or sinking in water, or you can be knowing with specific gravity. Now coming to the practical application, if you see an auto mechanic, to check his battery, he should understand what is the specific gravity of that fuel. Similarly, for a chemist, chemical engineer, how the reaction has been doing, whether it is fast or something, some portion of specific gravity is helpful to understand the reaction. I hope you are clear with specific gravity. Next point I want to tell you is, specific gravity is also known as true specific gravity. Specific gravity is also known as true specific gravity. And remember students, specific gravity varies between specific gravity G varies between 2.6 to 2.9. Again, I will tell you students, some people will tell you for organic soils different and for inorganic, but this range is more than sufficient. 2. G specific true specific gravity varies between 2.6 to 2.9. Next one we have is the mass specific gravity. Now you can ask me, what do you mean by mass specific gravity? Mass specific gravity is also known as apparent specific gravity. Mass specific gravity also known as what, students? Mass specific gravity is also known as, it is also known as apparent specific gravity. Mass specific gravity is also known as apparent specific gravity. Now see, students, when I tell you about mass specific gravity, what exactly is mass specific gravity is, it is the ratio of bulk unit weight to the unit weight of water. Now mass specific gravity varies from state to state. If it is bulk state, it is gamma by gamma W. If it is dry state, if we tell you about dry state, Gm is equal to gamma D upon gamma W. So based on the condition of the state of the soil, the mass specific gravity will vary. And if you consider Gm in saturated state, it is gamma sat by gamma W. So in mass specific gravity, you will consider the state of the soil and you will be comparing with the water. That is called mass specific gravity. For now, you write it as a note, student. You write it as a note. What is that note is, specific gravity is always greater than specific gravity. You write it as a note, students. This is very important. So please write it as a note. That is, specific gravity, true specific gravity is always greater than mass specific gravity. Sorry, students. This you write it as a note. Okay. Now for this explanation, I will be telling you afterwards. Okay, don't worry that via. Now see, students, how specific gravity is determined. We have different methods, students. How specific gravity is determined, we have different methods, but out of those things, the important method is pycnometer method. Specific gravity is determined by a method called pycnometer method. Specific gravity is determined by a method called pycnometer method. Gravity is determined by the method pycnometer. When I tell you about pycnometer method, what is the exact procedure here is, I'll tell you with an example. Specific gravity is determined by a method called pycnometer. Now see, student, take weight of pycnometer, MET pycnometer. This is W1. Another thing is same beaker, weight of pycnometer plus solids. This solids. This is W2. What is solids plus water? Solids plus water. Take it this as solids, this as. So, and what is W4 is, I'm not telling again, student, what is W1. By looking into the diagram, you might be aware of what is W1, what is W2, and what is W3, and what is W. Here W4 is full of water. Here it is full of. So this is what W1, what is W2. Again, they might ask you. So that is the reason, by looking into the diagram, you will have an idea. Full of water or full water. So students, now what do you mean by specific gravity is, it is determined as G equal to gamma S by gamma W. Now these, students, you should be very clear in understanding this. Now can I write gamma S? By definition, it is written as weight of solids to the volume of solids. See, students, most of the people don't know how the derivation came. That is the reason in any problem solving you should have an idea. And gamma W is known as weight of water by volume of water. So if I write the equation here, G is equal to weight of solids. Gamma S can be written as, from the above things, gamma S can be written as weight of solids by volume of solids upon weight of water divided by volume of water. Now see, students, when can I cancel these two? When volume of solids is equal to volume of water. That means Here you have to calculate the weight of solids that is occupied in the volume of water. That is important. Or see, or weight of water that is occupied in volume of solids. Am I clear or no? See student, when can you cancel Vs and Vw is when both are equal. So for simplification, now can I write G is equal to from this weight of solids by weight of water. Now from these two things, W2 and W1, weight of solids can be written as from it is evident that weight of solids is W2 minus W1. Am I correct or wrong? Now you have to find out the weight of water that is occupied in the solids volume. That is occupied in the solids volume. Am I correct or wrong? See students. Now see students. I'll tell you. What is W2 minus W3? What is W2 minus W3? It is minus weight of water. Minus weight of water in where area? You can minus weight. W2 minus W3 is minus. And what do you mean by W4 minus W1? What is W4 minus? It is the weight of water, right? What is W4 minus W1, students? W4 minus W1. W4 minus W1 is nothing but weight of full of water. Weight of full of water. W4 minus W1 is weight of full of water. Am I correct or wrong? W4 minus W1 is weight of full of water. Now see students, if I add these two portions, if I add this, you will get a weight of water in the solids content. That means you will get weight of water in this region, students. This region, what is the weight of water? Then only you can cancel, students. Then only you can do. So what is this? So weight of solids is weight of water can be written as. So total formula will be derived. You see here, G is equal to W2 minus W1 upon W2. If you add those two, this is W2 minus W1 minus, if you take common, minus W3 minus W. So this is the formula for specific gravity. See students, again I am stressing on this derivation because frequently you have doubts on this. Here G is equal to gamma S by gamma W. G is equal to gamma S by gamma W, and gamma S is taken as weight of solids to the volume of solids, and gamma W is taken as weight of water to the volume of water. Now how can you calculate, how can you cancel Vs and Vw is when both are equal. When these two will be equal is when the weight of water that is occupied in solids only. If you find out that only, then only volume of solids and volume of water. Finally the specific gravity formula is W2 minus W1 upon W2 minus W1 minus of W3 minus W4. So this is the formula for specific gravity. I hope everyone is clear. Okay. Now see students, in the today's class, and I want to derive some important relations. See students, some people will feel these are not, when you derive these things, there are different approaches, but I will be following one approach. There will be different people, different approaches will follow, but my approach is different. Okay. Now see students, now if you want to derive a relationship between E, W, G and SR, if you want to derive the relation between these four, what is E? E is nothing but void ratio. What is W? Water content. What is G? Specific gravity. What is SR? So with these four, what is the relation I want to tell you is, now see students, water content is defined as weight of water to the weight of solids. Now see students, as you know, by definition of water content is defined as weight of water to the weight of solids. But from the definition of unit weight of water, gamma W is defined as weight of water to the volume of water. And from gamma S is defined as unit weight of solids, that is weight of solids upon volume of solids. So if I take from this, weight of water is taken as gamma W into VW, gamma W into VW, and WS is considered as gamma S into VS. So here you should be very clear, students. Water content is equal to gamma. If I substitute what is water content formula here, that is gamma W into VW from this equation, and what is WS is gamma S into VS. So if I solve this problem like this, can I write like this as VW upon VS? This equation can be written as gamma S by gamma W. So what do you mean by gamma S by gamma W? Can you tell me, students? G is nothing but gamma S by gamma W. Remember, students, G is nothing but gamma S by gamma W. From this, the equation can be written as VW by VS into G. Now see, students, here in the left hand side you have water content. Now see, students, VW by VS, what I will do is I will multiply with volume of voids on the numerator as well as on the denominator. I will multiply with volume of voids on the numerator as well as on the denominator, multiplied by 1 by G, multiplied by 1 by G. Now see, students, in the previous session I told you what is volume of water by volume of voids and what is volume of voids by volume of solids. If you see the relation, this can be written as volume of water by volume of voids can be written as degree of saturation, and volume of voids upon volume of solids is written as void ratio. So upon G. Now if you see here, from this you can find out that E is equal to water content to G upon SR is the formula. See, students, lot of competitive, when you see in SSC JE, in any public service commission, if you name Andhra Pradesh, Karnataka Public Service Commission, anywhere, usually these kind of relations are very important, and these are very important even in GATE also. So please note what, see, students, every year in properties of soil we are seeing a 2 marks question. So this is very important. Okay. Now the next relation what I want to tell you here is, now we are done with the EWG. Now what is the formula for gamma? Now we are going to discuss about what is the formula for gamma. Before moving to gamma formula, I will tell you the basic of what is gamma. If you remember, gamma is equal to what, students? Gamma is equal to weight of water plus weight of solids upon total volume. Students, if you don't know the derivation in problem solving, you cannot approach. There are some problems where you can solve the problems using direct formulas and through the derivation. That is the reason I am telling all this derivation. The previous derivation I told you what is the formula for weight of water and as well as weight of solids. From it is evident that weight of water can be written as gamma W into VW, and weight of solids can be written as gamma S into VS upon V. Am I clear? Students, are you getting any disturbance? In the yesterday's class someone has told is you are getting. If you have any disturbance also or any kind of doubts, you are always feel free to ask me. Now see, students, what is volume? Volume is written as volume of total volume is written as what, students? Volume of voids plus volume of solids. Now in this equation, if I take volume of solids common, this will be written as 1 plus volume of voids divided by volume of solids. So this equation is written as Vs into 1 plus E. This is already known to you. So from this what I can write is gamma is equal to gamma W into VW plus gamma S into Vs upon Vs into 1 plus E. So this is the relation you are going to develop with gamma. Now see, students, if I take gamma W and Vs as common from the above equation, it can be written as VW by Vs plus gamma S by gamma W. So this is what you have written in the from above equation. Now see, students, upon Vs into 1 plus E. So it is Vs into 1 plus E. Now from this, if I cancel Vs and Vs, gamma can be written as gamma W into, what is gamma S by gamma W? If you remember the basic definition of G, that is gamma S by gamma W. So this is written as G. VW upon Vs can be written as VW by VV to VV into Vs. I am multiplying with volume of solids and dividing. So there will be no farak. So divided by 1. What is VW by VV? It is nothing but degree of saturation. What is VV by Vs? It is void ratio. So finally the equation is gamma is equal to gamma W into G plus E into SR upon 1 plus E. Very important. Very important formula. So please write down, students. Gamma is equal to, no need to write anything, students. Whatever the formula I am having, I will be uploading, I will be sharing the notes of this after the class. So gamma is written as gamma W into G plus E into SR upon 1 plus E. So see, students, now you told me that gamma is equal to, what is the formula you told me? Gamma W into G plus E into SR upon 1 plus E. This is the formula which you have told. Now see, students, gamma will become gamma D. Remember, students, gamma will become gamma D. And remember, students, gamma will become gamma sat. Remember, students, gamma will become gamma D and gamma will become gamma sat. This is very important, students. Gamma will become gamma D when degree of saturation is 0. That means when dry state, degree of saturation is what? 0. And gamma will become gamma sat when degree of saturation is equal to 1. That is fully saturated. So using these two conditions, I will derive this formula. If I substitute SR is equal to 1, you will get gamma sat formula. So if I substitute, gamma will become gamma will become gamma sat. That means when SR is equal to 1. So here gamma sat formula is, you have to remember this, students. Gamma sat is equal to gamma W into G plus E upon 1 plus E. So this is the standard formula for gamma sat. Remember, students, these derivations just are very simple. If you know one derivation, all the derivations will be simple. Similarly, gamma will become gamma D when SR is equal to 0. So gamma D is equal to gamma W into G upon 1 plus E. So this is the formula. Okay, this is the formula. Okay, and one more thing, students, some people might have asked this formula also, but this thing, gamma W into G plus ESR upon 1 plus E. Okay, see, students, gamma is equal to gamma W into GSR plus 1 plus E. How this formula can also be written as gamma is equal to, if I separate the formula, gamma W into G plus E. See, students, I am just multiplying whatever there in the bracket upon gamma W into ESR upon 1 plus E. See, students, the continuation part will be in the next slide. Now see, student, gamma is equal to gamma W into G upon 1 plus E plus gamma W into ESR, right? So I will take, what I will do is SR I will take common, instead of E will be there, student. Can I write E like this, students? I will add G and minus G upon 1 plus E. Now see, students, gamma can be written as gamma W into G upon, students, any kind of doubts you are always feel free to ask me. Gamma in the comment section, if you have any doubts you can write. This, if I multiply this, if I take this as A term and this as B term, so gamma W into G plus E Sorry, students. Okay, gamma W into G plus C upon 1 plus E minus gamma W into G upon 1 plus. Now, so see students, in this I am taking a common SR. I am taking SR as common because SR is there. I have taken SR common and I have multiplied this gamma W. Now, if you see what is this formula? This formula is for gamma D. So, gamma is equal to gamma D plus SR into what is this formula, student? This formula is for gamma set. So, gamma E can be written as gamma D plus SR into gamma sat minus gamma D. This is another important formula where you can find out. Okay, but students, you need not to remember this formula, but they can ask you. If they ask you they can ask you how the question is. Can you explain the relationship between gamma D, SR and gamma set? If they ask you the relation between this, then in that case, if you don't know this formula or the basic approach, if they ask you they give you the four variables and they ask you the relation between them, then in that case you should be clear about those relation. So that is the why I have derived this relation. And one more relation is there, students. That part I will be telling in compaction. But for now, see students, gamma D is equal to 1 minus Na into what is the for now. This is a relation I will explain you in the compaction topic. But for now, gamma D is equal to 1 minus Na into 1 plus water content into G. And see students, we have not discussed about percentage of air voids. Now I am going to tell. That is the reason I have not explained there. Now see. Now in this slide, I am going to tell you about what is the percentage of air void. Now we have a term called percentage of air void. See students, whenever they ask you about percentage, remember percentage means you have to just multiply with 100. So that is also very important. Coming to the percentage of air voids, what do you mean by percentage of air voids is it is Na is equal to what is percentage of air voids? It is defined as Na. Na is equal to volume of air to the total volume. Okay. Yes, volume of air to the total volume. So what I will do is Na can be multiplied with volume of voids on the numerator side as well as on denominator. So what is volume of air upon volume of void, students? It is nothing but air content. And what is volume of voids to the total volume? That it is called porosity. This Na can be written as N into AC, air content. What is N, student? N is known as percentage of air voids, can be written as porosity into air content. Now see students, whenever I am explaining percentage of air voids is porosity into what is percentage of air voids? That is porosity into air content. So here in this case, what I will write is what is the range they can ask you. Range of Na is, see students, this is very important. Percentage of when air content is 0, percentage of air voids is 0. That means when air content is 1, Na will be equal to N. So that is the reason the range of very important student, the range of percentage of air voids is 0 into N. One more thing for students, here it is percentage, no, so it will be multiplied with 100. Okay, I forgot. Here in this name it is percentage of air, so hence it is multiplied with this thing. And one more important relation I want to tell you, and this relation will be used in various problems. You told gamma is equal to gamma W into G into ESR upon 1 plus E. This is the relation you have told. Now see students, you remember void ratio is equal to water content into G upon R. From this you can write E into SR is equal to water content into G. E into SR can be written as water content into G. So if I write here gamma is equal to gamma W into G plus what is ESR, students? ESR is nothing but water content into G. So you can write it as G plus water content to G upon 1 plus E. So from this, if I take G common, it can be written as gamma W into G upon 1 plus E to water content. This is very important. From this, what is, students, what is gamma W into G upon 1 plus C? Now see, students, from this, any doubt, students, please comment. What is gamma W into G by 1 plus C? It is nothing but the dry unit weight. So gamma is equal to written as gamma D into 1 plus water content. From this, gamma, very very important, student, gamma D is equal to gamma upon 1 plus D water content. A very very important formula. Please keep a note of this. Please write down or otherwise gamma D is equal to 1 plus water content. Okay, students, I hope you are clear this concept. Any doubts, students? You can always feel free to ask me. Now see, in this slide, what I am going to discuss is the order of the unit weight. Order of unit weights. This is, what is the order of? Now you can ask me, what is the order of unit weights? This is also very important, student. The order of unit weights are nothing but how I will tell you. Have to be very specific in finding out what is the order of the unit weight. Suppose here, if you see, what is the formula for gamma? Gamma is told W into G plus ESR upon 1 plus. Students, if you don't know this relation, you cannot find out this. The gamma D is written as gamma upon 1 plus water. I will tell you first for this relation. Gamma sat is written as gamma W into G plus E upon 1 plus E. So G plus E upon 1 plus E. What is the formula for gamma set? G plus E upon 1 plus E. So this is the relation for gamma. Now see, students, anyone you can tell me which is, out of these two, which is higher? By basic mathematics, here gamma is written on the numerator side and the denominator is always greater than 1. So definitely gamma D is less than gamma W. Yes or no, student? From pure maths, what is 1 plus water content? Definitely it will be more than 1. Anything divided by more than 1 will be lesser than the numerator. So it is evident that gamma D is less than gamma. Now the relation between gamma sat is always greater than gamma. Why? I will tell you. Most people don't aware of this. You will ask me, gamma is written as everything is same. Here in gamma, it is taken as ES. Sorry, I will tell you in this way. In gamma, there is a concept called ESR. I will tell you in other color so that you can distinguish with them. Gamma, you have taken it as ESR, students. Whereas in gamma sat, it is E. Now, can you tell me whether ESR is more or E is more? Can you tell me? Whether ESR is more or E is more, can you tell me? That is a simple thing. ESR, people will think that ESR is more. That is absolutely wrong. ESR is less than 1. Why? Because SR is always, what is SR? See here, what is the value of SR? When SR is always 0 to 1. Actually, it will be equal to 0 and it will be equal to 1. But when E is when SR is equal to 1, what is happening? It will become gamma set. SR is equal to 1, gamma will become gamma set. So ESR is always less than E based on the range of the degree of saturation. So from these relation, I can write it as gamma sat is greater than gamma D. Now you will ask me, what is one more relation? In gamma sat, remember, if you see the formula of gamma S, that is weight of solids by volume of solids. And remember, in the denominator part, in gamma sat, you will have total volume. What is gamma sat means? Weight of water will be very less. weight of water plus weight of solids by total volume, but here the denominator is very less. Hence, gamma S is greater than gamma sat, and always gamma dash will be gamma W will be the, some people will see and submerged unit weight will be the lesser value, because gamma dash is considered as gamma sat minus gamma W. If you see this relation, you can understand. So gamma S is greater than gamma sat, because this was a previous IES question, students. Remember, gamma S is greater than gamma sat, greater than gamma, gamma D, gamma dash and gamma W. See students, in some cases gamma dash might be lesser than gamma W, and some cases gamma W will be greater than. So actually the question it was asked is these three relation only, but for your practical observation I have found it up to here everything is correct up to gamma D, but sometimes these things will vary. But they can ask you what is the descending order. This is the descending order. If they ask you ascending order, you have to start with gamma W, gamma dash. When you write larger to smaller, that is descending, and if you write smaller to larger, that is ascending order. So that is also very important, students, because they can ask you what is the ascending order of unit weights and what is the descending. Whatever I have told in this is descending order of unit weights. If they ask you from ascending order, it will be lower to higher. I hope your order of unit weights is very clear with you. Okay, now I hope you are enjoying the sessions. Meanwhile, see students, if you like this video and all, please follow us. This is Civil Engineering E-Tab channel, and please, these are the links for YouTube, Facebook, Twitter and Instagram. And one more thing I want to tell you is, please, as a boost of confidence for our team to give more and more videos and more innovative videos, please like, share and subscribe. This is the most important part for our motto or for our self-confidence to give best of our thing. Okay, thank you, and we'll move on to the topic now. I don't want to stress on those words as a part of the thing we are doing. Next one, after the order of the unit weights, next one what I want to tell you is, there can be a previous gate questions. See students, there can be a previous gate questions or some of the problems related to this topic. Before moving to the problems, there is another problem. This is a practical problem which I will see students. If I consider this as a fill, see students, it is a fill I am telling you, and this is a borrow pit. Okay? Borrow pit. You will ask me, sir, what is fill and what is borrow pit? Suppose if there is a soil, you are taking the soil from a pit and you are trying to fill this soil here somewhere. Now see students, these kind of problems are very important. If I take fill as unit weight is gamma 1 and water content as WC1 and E as E1 and volume as V1. Similarly, if I take here gamma 2, water content 2 and E2 and V2. See, please follow this very important student. Now, sir, why you will ask me the first question, sir, what is the purpose of learning this topic? This topic is, if you are having a foundation, you have to fill that when you are digging for for pillars and everything, you will dig you will do excavation, and after that excavation you will fill that fill with some soil. For that soil, how much soil you have to bring from the borrow pit? These kind of problems are very important. Now see students, if gamma 1 and water content are given, you should convert them into water content. First, you should convert them into dry unit weight. You have to convert them into dry unit weight, that is gamma 1 upon water content, and here also gamma D2 can be written as gamma 2 upon 1 plus water content. Am I clear students? Now see students, this is a very important relation. Now what is a relation I want to tell you is, gamma D1 or gamma D2, whatever, the formula is weight of solids upon total volume. This is a very important concept, students. As I told you, for unit weight of solids, when I tell you about unit weight of solids, remember, for any soil, weight of solids is constant. Weight of solids are nothing but weight of soil is always constant. How I will tell you? Suppose if you are bringing weight of soil is constant. Suppose if you are bringing 100, suppose 2 tons of soil from year to year, will the weight of soil will vary? No. Don't, if it is 2 tons, here also it will be 2 tons. So weight of soil is always constant. But after bringing here, you will be doing compaction and thereby the volume changes. So here what I can write from this relation is, as weight of solids is constant, gamma D1 is inversely proportional to volume. Why I have not written weight of solids is because weight of solids in borrow pit or in fill, in both the cases it is same. So from this I can write gamma D1 by gamma D2 is equal to V2 upon V1. Am I clear, students? Now in the previous solution, students, I wrote you total volume can be written as volume of voids. In the previous session I told you, and today also. And this can be written as Vs into 1 plus C. This is straight away I am writing. Again, see students, again when weight of solids is constant, volume of solids is also constant. From this also, volume is proportional to 1 plus E. So this equation is written as 1 plus E2 upon 1 plus E1. Very, very important relation. Whenever you are solving some problems, this relation is very important. Remember students, gamma D1 by gamma D2 is equal to V2 by V1 is equal to 1 plus E2 by 1 plus E1. This is a very important relation in solving the problems. I hope you are clear in this topic, and you can put a star mark. Remember student, when I am writing in the notes, when I put something in box, as I told you, whenever you are writing the formula, lot number of formulas will be there in soil. So whatever the formulas which I am writing in box, so please take it as a note and please solve those. Okay, I hope you are enjoying the sessions. Now coming to the problems, I want to discuss some problems, even though they are easy and all, as part of this chapter. See, some problems I will be discussing in the class and some problems I will be discussing in the later part. In the means, I want to tell you, I will be discussing in the otherwise I will upload the videos. Okay, don't worry that I have not done a, okay, the problem. Am I clear students? Give me a second. Example 1. Example 1 is a sample of dry soil, a sample of dry soil, sample of dry soil weighs, sample of dry soil weighs 120 grams, sample of dry soil 20, and its volume is 80 ml, and its volume is 80 ml. If the specific gravity is, if the specific gravity is 2.80, the void ratio of the sample is, okay, see students, tell you the solution here. See, in this problem, weight of the soil is given as, weight of soil is given as 120 grams. Weight of soil is given as 120 grams. Volume is given as 80 ml. From this, if I calculate gamma D is equal to what students? Weight of soil upon total volume. Weight of soil upon total volume. What is the weight of soil here students? Weight of soil is nothing but 120 grams. upon 80 ml. Now see students, you will ask me, don't see students, these conversions you should be very clear. 1 meter cube is equal to 1000 liters. 1 meter cube is equal to 1000 liters, and 1 liter is equal to 1000 cc or 1000 centimeter cube or 1000 ml, both are same. So from this, gamma D can be written as 1.5 gram per cc, because I am converting, because we know gamma W units in this, that is the reason. And you know gamma D is equal to what, students? Gamma D is equal to gamma W into G upon 1 plus E. So that is the relation. From this, gamma D is equal to how much, students? 1.5 is equal to, what is gamma W? 1. So 1 into 2.8 divided by 1 plus E. If you solve this, 1 plus E is equal to 2.8 divided by 1.5. That will be around, if we do this, 1.86, I think. It will be around 1.86. So if I do E is equal to 0.86. Am I clear, students? So with this, we are done with this problem. Am I clear, students? Any doubts? So this is the first example. And one more thing I want to tell you, students, in the problem section, please don't worry that I am not taking any problems in the class. Whatever the problems which are means typical problems, previous gate questions on this chapter will be uploaded as separate videos. Those will not be taken in the live session. So what I will do is, after completion of every chapter, today I am going to complete properties of soil. The problems related to previous years and all those things will be uploaded in this video. So don't worry. Okay. Next question, students. The next question is, example 2 is, the true and the apparent specific gravity, the true and the apparent specific gravity of a saturated soil or apparent specific gravity and the apparent specific of a saturated soil or 2.7 and 2 respectively. 2.7, 2 respectively. And one more thing, here you write it as fully saturated. Again, you will ask that doubt. The true and apparent specific gravity of a fully saturated soil are 2.7 and 2 respectively. Calculate void ratio E. Void ratio is the void ratio. You have to. Now, when you are doing this, the simple solution here. See, student, what is the true specific gravity of fully saturated? So G is equal to, given as, this problem is but easy to know that. Now I told you apparent means it is nothing but mass specific. So mass specific gravity is, how to solve this problem is, see students, GM is can be written as gamma sat by gamma W. Why I am taking gamma sat by gamma W? Why I am taking gamma sat by gamma W? Because is stated that the soil is fully saturated. So hence I have written that as gamma sat by gamma W. And you know what is the formula for gamma sat, student? Gamma sat is written gamma W into E plus E upon 1 plus E, E plus E upon 1 plus E. Am I correct or not? So here you should be very clear in this, G plus E upon 1 plus E. So from this I can write it as gamma sat by gamma W, gamma sat upon gamma W is equal G plus E upon plus E. Now from the above equation, Gm is written, gamma sat is by gamma W is nothing but 2. So you write, substitute here 2 is equal to, what is G, students? 0.7 plus E upon 1 plus E. If you solve this, 2 plus 2E is equal to 2.7 plus E. That E is equal to 0.7. So here I told you this is very important. Okay. With this, what I want to tell you is, students, is I'm done with the properties of soil chapter, and I want to do a quick revision of this chapter. Okay, students, I want to do a quick revision of this chapter in a single side. And don't worry that I have not taken the problems. All the problems will be uploaded offline. Okay. So see, students, the summary of properties of soil. If anyone, you can take a photo or anything and you can remember at your. Now what is the summary of properties of soil is, I will cover in this slide only, my intention, or at least 2 slides. See here, students, soil is represented as 3-phase system. I'll write in 3-phase system as well as 2-phase. Next, void ratio is written as E is equal to VV upon Vs, and range of void ratio is always greater than 0. And porosity is written as, the relation between porosity and N is written as N is equal to E by 1 plus E, or total volume of voids by total volume. And air content is defined as volume of air to the total volume. And degree of saturation, air content is defined as volume of air to the volume of voids. Degree of saturation is written as volume of water to the volume of voids. And remember, air content plus degree of saturation is always equal to 1. One more, and next thing what I want to tell you here is, next thing what I want to summarize here is, what is water content? Water content is equal to weight of water by weight of solids. And what is the range of water content? Water content is always greater than. And remember, students, water content is derived or determined by oven drying method. And remember, you have to write down what is oven drying method is the most accurate method. And remember, here it is the most accurate method, and the quickest method is nothing but calcium carbide method. What is the quickest method? Is calcium carbide method. This calcium carbide, what is the gas released in calcium carbide? They can ask you. The gas released in calcium carbide is nothing but acetylene. They can ask you this also. What is the gas released in water content? Is acetylene. Sorry, calcium carbide is acetylene. Next one, what I want to tell you is the important relationship between gamma and all. Those formulas I will be writing now. E is equal to water content to G upon SR, that is, and another relation is gamma is equal to gamma W into G plus ESR upon 1 plus E. And next thing is gamma D is equal to, I am writing very clumsy, if you feel that I am, because I want to complete in one side. Gamma D is equal to gamma W into G by 1 plus E. And remember, gamma sat is equal to gamma W into G plus E upon 1. These are the relations. And one more relation is gamma is equal to gamma D upon 1 plus 4. And you have another relation, Specific gravity is determined by micrometer method, that is W2 minus W1 divided by W2 minus W1 minus of W3 minus W4. So this is the relation for specific gravity. Okay. Next thing what I want to tell you here is, discuss is the excavation problems. Remember, gamma d1 by gamma d2, v2 by v1 equal to 1 plus e2 by 1 plus e1. This is another important relation which I want to tell you. And one more thing what I want to tell you here is, uh, gamma sat S is greater than the descending order of the units, right? Gamma sat gamma, next gamma d, gamma dash is gamma w. This is another important thing which I want to. With this we are and another important formula, gamma d is equal to minus Na w into g, gamma w into g upon 1 plus water. You can write Na is equal to also volume of air divided by total, and Na is written and porosity into air content. This is the entire summary of this chapter. You can follow. Okay, thank you. And see students, again I am telling you, the only boost up you can give us is, please like, share and subscribe. For watching the videos of, please subscribe our channel. As I told you again and again, please share and ask your friends to subscribe. Try to attend online classes as much as you can, as I feel it should be an interactive session, so that it will be very interesting for you. Is a boost. Thank you one and all for attending. Have a nice day.